Hello and welcome to another Zozin session. How about that? So today, I'm gonna continue working on the same shit. So yeah, I kind of really went very deep into this project and people already throwing money at me. I didn't do anything, people already throw money at me. Thank you so much Trond CJ for a tier 1 subscription, your first subscription by the way. You're gonna be at the beginning of the video. Be proud of yourself. Thank you so much, thank you for the support. So yeah, I'm really deep into this project. I don't fucking know why. It's the most useless project I've ever worked in, but it's usually like that, right? So it's usually the most useless projects that hook you up, and it's just like, yeah, there's nothing I can do about it. So you can find the source code of this project in here if you're interested. It's just like a tile generator. It's actually not the point of today's stream. Right, so even though we're going to be working on this project is not really the point of today's stream. The point of today's stream, okay, not the point of today's stream, but still the source code. There we go. Right, so this particular project has a command line interface, right? So let's take a look at this thing. Right, so if you do something like this, it generates the tiles or whatnot, but you can then do help, and it has like a couple of flags that you can customize and stuff like that. Actually, we have more flags. I think I need to fetch the latest stuff. So let me see, I need to check out the master, and I'm gonna fetch prune origin. Right. So, and git merge origin master. There we go. So let's remove the previous branch, and there we go, and I'm gonna rebuild everything. Cool. So if you take a look at flags now we have way more flags. Look at that, look at this amount of flags. So yeah, it has a command line interface and stuff like that. And the way we actually handle all of that is we handle and parse everything manually. We're not using any special libraries or anything like that. Like, I literally take the array of argv, so array of arguments, and I just iterate manually through each argument, and I just parse everything accordingly. That's the way I do, that's the way I go. So the software must be simple, right? But that introduces kind of a problem, right? So let's take a look at how it's done right now. So I have a bunch of parameters. So here parameters correspond to their flags and stuff like that, and they have default values. Then I iterate through each individual argument, right? And if I encounter a particular flag, I handle it, just extract the arguments and set everything, also check if the value is correct and whatnot. If the value is not correct, it fails, you know, pretty straightforward stuff. Right, and on top of that, I have a function that prints the help for the user, an explanation for each individual flag. So essentially, whatever you see in here, I print it in here. So to add a new flag, I have to make pretty much the same modifications in two places, right? So I have to add a flag in here, so it's going to be fprintf strmf. So I basically first need to add documentation, something like new flag. Right, so all of you in the chat are new flags. Sorry. So and then I'm gonna add the new flag. This is the documentation, right? So I added the new flag, and then I have to not forget to go to the place where I parse the flags, right, and add the check in here. And you see, the fact that I have to modify two places is actually pretty meh, if you know what I'm talking about. Right, so it's not particularly convenient to modify shit in two different places. So, and what I want you to do today is I want you to develop, you know, some sort of like a small library for parsing flags in this particular style. So I could have used something like getOpts, but unfortunately getOpts sucks as an industrial vacuum cleaner, so because of that I can't really use this library in my project. So, and I was thinking about alternatives, and recently I programmed a little bit in Go, and Go has a beautiful module for parsing flags. It is called Go Flags, and it is precisely what I need. So you can find it in here. It is absolutely beautiful. It's so simple. It's like a no bullshit library. Like, it does precisely what you want. No more, no less. It's just like beautiful. Have you guys worked with this library? Have you guys worked with this library? So has anyone worked with this thing? I'm gonna leave it in the description. So this is precisely what I want. So where is my description? And I was thinking, can we have the same simple good shit, but in C? Can we have good things in C already? Holy shit, it's 2021. So goes flag module, right? So here's the goes flag module. So let's take a look at it. So I'm gonna actually probably go to this project and so go flag prob. So let's give it a try. So it's gonna be main go, right? So I don't remember how to program go. I think it's a package main, right? So I'm gonna put a semicolon in here. Okay. So, and then we probably also need to import FMT. I'm gonna put a semicolon in here as well. And then FMT printf hello world, and not forget a semicolon in here. Okay, so oh fuck, I didn't mean to do that. What was that? GNU. What the fuck is this? How did I open that? I don't know how did I open that, but okay. So, and if I do go build main go, yeah, the KGB hacked my PC, so I didn't mean to actually go there, but somehow I went there. Okay, so we have a hello world, and there we go. Here is the hello world. So, to start using flags, I think it's like a standard thing. You see, I'm using a separate import, right? I'm using a separate import, not in the same, not in this on the same line, and I'm also using semicolon. So I'm using separate import and also semicolon, and there. It's quite important. It's quite important. Okay, so let's rebuild the entire thing. I think you can just run the application like that. Okay, so flag is not available for some reason. So import flag, is that because I have to install it first? That's really strange. Oh yeah, because imported not used. All right, so that's fine. So imagine that you want to now parse a particular flag, right? So you have to call a function of the type that you want to use. For example, flag int. Is there any list of all of the functions in here? So here is the index. I can see the index. Yeah, there we go. So for different types, you have separate functions, right? And in our case, I suppose we want to use int because we want to parse the int. I wish I could just, you know, enlarge the text, but unfortunately the left panel goes away. Maybe it goes somewhere here. So, and when I try to click on this thing, nothing happens. So this is a very cool website. Maybe I can, yeah, I click on any of these things. They just don't work. They just don't work. It's a 2021 software. Nothing fucking works. And now everything disappeared, because I clicked too many times. So I exceeded the limit of clicks for this particular website. So welcome to 2021 software, everyone. I have no idea what the fuck has happened, but it doesn't work anymore. So I'm trying to refresh. I'm refreshing the website. The website is dead. So fucking know, like, what's wrong with this entire shit? Yep, so now it works. And can I click on this thing? I still cannot click. What if I click on it several times, like as many times as possible? Will I exceed the amount of clicks for this website? So it seems to be like it shows me some, and now, okay. Okay, so I think I know what the fuck is going on, right? So I have to open this thing in here, right? So then click here, and if I go here, now it works. Thank you. Beautiful. So it's something with my Chromium. Anyways, whatever. So can I click here? And now it is working. So here the function accepts the name of the flag, the default value, and the documentation string. And look what it returns. It returns the pointer to the integer. So it basically allocates you a small space in the memory, like a slot in the memory. Here's where the value of the flag is gonna reside. And that's it. And this idea is extremely stupid and simple. Holy shit, I absolutely love it. So let's give it a try. So what kind of flag are we going to have? So maybe we're going to implement some of these flags like TW and TH. They correspond to tile width and tile height. Right, so maybe I'm going to have something like this. Flag int. It's going to be TW. The default value is going to be 64, right? And then I'm going to say the width of the tile in pixels, right? So, and then I suppose I'm going to assign it to TW, right? So, and maybe I'm going to put a P in here indicated that it's a pointer, but I don't want to do a Hungarian notation, so let's actually use a TW. Right, so, and then we can print something like tile width, and this is going to be just basically that. There we go. So if I just run it, tile width is 64, and then we might as well actually add more flags. Let's actually add tile height. So this is a tile height, it's also going to be 64, like this, and we're going to print it like that. So this is a tile height. This is the tile height. So we have a tile width and tile height. So it's not gonna work if I just try to do something like this, right? So if I do something like this, it doesn't work. So after you basically announced all of your flags, the thing you have to do, you have to parse them. You have to just do parse, I think. But I'm not quite sure. So I think it would automatically get everything I wanted. Yeah, you can actually just call it without any arguments. So you can just say flag parse, and what it will do, it will take the arguments of the program and parse them according to this description. This is a very dumb and simple description. Like I literally said, I have two flags, and for two flags, I just put 2 lines of code. And that's it. And I have a pointers to the places where they contain the value, right? So then I can do something like 256, and then the height is gonna be 256. There we go. And here it is. That's fucking it. That is fucking it. No bullshit nor anything. And this is such a beautiful idea. And the simplicity of this interface actually makes it obvious how it is implemented. You look at this interface, and you go, oh, I know how to implement this thing myself. It is actually super easy to implement this shit yourself. That's the beauty of the right interface, right? So it's just like, yeah, that's how it has to be done. None of this get opt bullshit, whatever the fuck it is. Like, what the fuck is wrong with that? Right, it's just that. And you can have different types and stuff like that. So it's just, yeah, this is what I want in C. Can I please have this shit in C? And today we're gonna have that in C. Today we're gonna fucking implement that. Oh, you can also do equals. Yeah, so you can also do equals because the library also handles that for you, right? So yeah, you only announce so the flags that you want to use. So unfortunately, there's a couple of limitations to this library. As far as I know, it doesn't support mandatory arguments, right? You cannot say that the flag is mandatory, right? You have to enforce it yourself. Usually, people enforce it how? They have a special value, a special default value like -1, and then after you parsed everything, you would check that if th is less than 0, then means throw an error or something. Okay, so we're gonna support mandatory values, by the way. We're gonna support mandatory flags. So we're not only gonna re-implement this shit in C, we're gonna improve it. And I have a pretty cool idea on how to have more flexible and customizable flags without overcomplicating the interface. Because one of the problems of this thing that I noticed, by the way, let me see. So it's gonna be int, where is int? Right, if you want to have additional things, right, you have to pollute the whole interface. Well, I mean, they don't really have that problem in here, so that's probably fine. That's probably fine. Okay. So the problem with mandatory, right? With mandatory, you'll have to add additional flag in here, right? Something like true or false or whatever, which basically complicates these functions. The more customizable you make the library, the more complicated this sort of function call will become. I have an idea on how to make these kind of things arbitrarily customizable without overcomplicating the interface, without adding more things in here. Right, I have a pretty cool idea, and we'll see how it will go. It may not go well, but at least I'm gonna try. Right, and here is the also a killer feature. Right, so here's the killer feature. What we can do, we can introduce something like a help flag, right? So it's going to be flag boolean, right? And it's going to be called help. I think initially it's going to be false, right? Print this help and exit, right? So print this help and exit. Then we parse, and if help is true, we're going to be doing something like so usage, is it called usage? I forgot how it is called. There was something like print defaults, right? So the function called is print defaults, flag print defaults. There we go. So you print defaults, and then we have to exit, and I wonder if I can just say exit 0, right? So now if I try to run this entire thing, undefined exit, okay, go exit, okay, so it's exit, so you need OS. All right, so I'm creating a separate line. This is OS. I forgot semicolons, by the way. You never forget your semicolons. Right, so and then I'm gonna do OS exit. There we go. So and then if I try to do that, everything is working. But now if I do help, it will print the help. So basically it took all of the information that we provided about the flags and it just printed them. So yep, which also indicates that there's some sort of a global state. So it stores information about the flags in some sort of a global state. But you know what? I think that is absolutely fine. You know why? Because these flags are global for the whole application anyway. The command line arguments of the program are global for the fucking whole program. That's why it makes sense to actually build this interface around a global storage. And of course you can actually not use a global storage. There's a variant to not use that, so there's a special functions to create the context separately if you need that. And there's also a ways to, for example, specify the storage, right? So instead of int, we could have called int var, right? And in here, instead of the value, you provide the pointer, and that's the pointer that you want to use if you want to control where exactly the values will go, and so on and so forth. So yeah, so that's basically the Go flag module. The Go flag module. And this is precisely what I want to implement today in C, because I like the idea. I don't like some specific and details about this particular implementation, but I'm gonna have like my own spin on Go flag module. So that's basically gonna be the idea. So where's the description? I already put this thing in here. Okay, let's go. Let's go. Does it sound good? Does it sound Gucci? Sound Tamaguchi? So, does anyone have any questions, maybe? Just a second. Immediate mode CLI. Is it really immediate mode? I don't think it's immediate mode. Maybe it is immediate mode. Okay, so let's go ahead and implement everything. So we're going to be implementing it inside of the Wang tiles, because this is where I need all of that. Right, so, and I'm going to be using the flag module to basically clean up this madness, right? So we're going to be cleaning up this madness. So far, we'll need things only for booleans. These are the booleans. Strings and integers, right? So we need to support only 3 types right now. As we add more different types, we're going to add more and more supports for different types in the future. And also, I think I'm going to actually move the flags module into a separate library, and I'm going to upload it to a separate repo so I can reuse it in other projects, because I want to reuse this kind of approach in my other projects, because I think it's very convenient. Okay, so let's create flag, and I think I'm gonna make it in a style of header-only STB library, right? So do you guys know what is a header-only STB library? Right. So the STB libraries, you can find them in here. You can find them in here, and basically each individual file in here is not only H, it's actually very special H. It's basically C and H files simultaneously, so it contains not only declarations of the functions, but also the implementations. And you can decide whether you want to include the implementations or not include the implementations, and you control that via the macros, right? So you define special macros, and the library acts like a C file. You don't define a special macro, and it acts like a header. So we're gonna implement our library in a similar style, right? I think it's a pretty good style, and it makes maintainability of the libraries pretty good. Though, how do you measure maintainability? It's also an interesting question. So maybe maintainability is not really applicable in here. So STB libraries. But it makes it super easy to just integrate the library into your C project, because you just copy paste it, you just include it, and that's it. You already integrate it with the library. You don't need any special build tools, you don't need any special package managers. You just, yeah, it's a single file, and there you go, you have it. Let's do the following thing. If not defined, flag .h, right, we're gonna define this thing. Okay, if it's not defined, we're gonna define it. Then we're gonna do end if. So this is basically the part where we have our own declarations. So this is basically the header part. The header part. Right. So, and usually this entire thing is split into the header part and implementation part. Right. So somewhere down there, we're gonna have the implementation part. So, how do you usually define implementation part? In STB style libraries, the implementation part by default is never included. It is only included when you define something like the library name implementation, right? So, and basically if implementation not defined, we're not gonna include the implementation part. There we go. So this is basically where you would put everything that you put in C file. This is where you would put everything that you put in H file, and this is for the C file. So basically you have H and C file simultaneously in a single file, right? So yeah, that's basically what it is. Does it make sense? Deep Singularity, what's up? What's up? What's up? How are you doing? Welcome, welcome, welcome. So, what we're going to be having in here, I suppose I'm going to go ahead and implement the main interface of the library, right? So I'm going to have something like flag bool, right? So here's a flag bool, and what do I want to provide in here? I suppose I want to provide the name, right? I want to provide the name, and I want to provide the default value, right? So does it make sense to provide the default value? I don't know. I think it does. I think it actually does make sense to provide the default value. I could use the default, and that will work in C. That will work in C, but unfortunately, it will not work in C++. And I think I want to make it workable in C++. So maybe I'm going to say something like def, I don't know, def, default. And also we want to have some sort of a description, right? So this is going to be the description. There we go. So, and this thing is supposed to return a pointer, right? And maybe we also need to include something like std boolean, right? Because we're using boolean directly. So then the next thing I want to have, we're parsing size t, right? We're parsing size t. But size t is uint64. So I think for a more generic case, we need to actually call this flag something like flag uint64, right? And it's going to have the same basically signature. So uint64t, default value, and then we are going to have the description. So for int64, we'll have to include stdint, and there we go. So, and the last thing we need to have is a string. So, yeah, this has to be a pointer. So the pointer to a string is going to be probably something like this, const char star star, right? So it's a pointer to a character, right? So it's going to be flag str, then we're going to accept the name, and then we're going to accept the default value. And then we're going to, I'm not even sure if I want to use const in here, because I think const will make everything complicated. But yeah, whatever. So we can change these definitions in the future. We can easily change them in the future. Okay, so this is the main interface that the user is probably going to be using. And the last thing we probably need in here is basically flog parse. Right, so, and we're going to be actually passing the argc and argv in here. Right, so argc and argv. There we go. So that's pretty much the whole interface that I wanted to have. And we just need to go ahead and implement it, I think. So this is going to be implementation. So false. Well, I mean, it has to be probably null for now. So this one does not really contain anything. Okay, cool. So where are we going to be storing all of that? Where are we going to be storing all of that? So I have an idea. We're going to have a limited buffer, right? A limited buffer where we're going to store all of the necessary information about the flags. So it's essentially going to be a global array of structures. And when you call one of these functions, you essentially return a pointer to the field inside of that structure. Right, so let's actually define what kind of flags we can have. So it's going to be enumeration, right? So it's going to be flag type. So it's not going to be visible to the user. That's why I'm defining it in the implementation section. And I think I have a logical mistake in here. If defined, well, you want to include it. Okay. So it's going to be flag boolean. Right now we only have flag boolean, then flag uint64 and flag string. There we go. So, and the structure that is going to be describing a single flag is going to look like this. So it's going to be type def struct flag, let's just call it flag, and it's going to store the type of itself. There we go. So here's the type. And now we need to have some sort of a union, right? We need to have some sort of a union. Union flag value, and here is the value. Right, and we're going to be reinterpreting that value as different type. But to be fair, like from the user perspective, since this structure is never going to be visible to the user, I don't think it matters to use union in here, because the user will always see the type safe pointer anyway. And look at all of these types. So we have boolean, we have uint64, and we have a pointer to the character. All of them fit into 64 bits, right? All of them fit into 64 bits. And there is a very interesting type in C. It's called int pointer. I think it's uint pointer underscore t. Yeah. So where can we find this entire thing? uint pointer t, unsigned integer, that the integer type capable of holding a pointer. So this entire thing is big enough to hold a pointer. So basically all of these types, pointer to this thing, boolean and uint64, they will fit into a single pointer. So what we can do, we can actually store the value. We can store the value. Wait, what? IP leaked? I don't think it's actually IP leaked. Is it really? Or do you want to be timed out? I don't think so. I guess you just wanted attention. Okay. So 2 hours timeout for you. Okay. So let's continue. So this is going to be uint pointer underscore t, and this is where we're going to store the data, right? This is where we're going to store the data. Right. So, and basically when this entire thing returns a pointer, it returns a pointer to this, you know, particular memory, right? So it will return here. And since we're reinterpreting this entire thing, it's going to be fine. So we don't need any unions in here. All right. So, and we're going to have a global sort of array of these flags, right? So here's the flags, and we're going to have like a flags capacity, right? So there we go. And it's going to be static, of course. And as you add more and more flags in here, right, so it's going to be flags count, right, initially 0, and it's going to be static. There we go. Okay, so we need to define the flags capacity. So it's going to be flags capacity. How many flags do you want to define? By the way, how many flags is enough for a regular application? So is 100 flags enough? So maybe 256? What do you guys think? So maybe more, maybe less. You know what? I think we can actually make it customizable. So basically, you only do that if it's not defined. Flags capacity, right? So we only then define it. So at any point, you can actually redefine it if you want to, right? So ndif. So if this is not enough, yeah, it's gonna work. All right, so there is another thing that we probably need to store in a flag structure, right? Not only the type, we need to store the name and the description, right? The name and the description. Const char name, const char description. So we probably want to also store the default value, but maybe not. So I had the following idea. That you can basically define something like help and then flag help, and you can only specify the name and the description, print this help message and exit, right? Print this help message and exit, and then to specify the default value, right, you basically assign it to false. And here is your default value, and then you do flag parse, right? Then you do flag parse. So, but here's the problem. I want to be able to actually, we need a print, like print help. So let's do something like flag print help, right? Where I suppose we would provide the stream where exactly you want to print it. You want to print it to the standard out, you want to print it to standard error and stuff like that, right? So it's going to be flag parse, and there we go. So and here's the problem. I want the help to actually print what is the default value if there is one, right? So I want it to print it. And since this is the way you define a default value, this is not particularly convenient. Or maybe it is rather difficult to tell. So maybe before parsing anything, the flag parse will go through each and individual flag, take their initial values and remember them as default values, so then it can print them in help even if they modify. Okay, that's actually a pretty good idea. Yeah, so that's a very interesting idea. So maybe because of that, you never actually have to define the default values, right? So because the library itself can derive that information, the only thing you need is name and description. What is the name and description? Then you can set the default value, right? And then flag parse will collect all of the default values of the current values and will use that in the documentation later. Sounds good to me, actually. Sounds pretty good to me. And we can even do something like, so here is the data, here is the actual data, and we can do something like default, right? So this is where we're going to be storing the default thing in here. Which we can use then later for the printing help. Okay, and look how simpler the interface become. So let's go. So this is how it's gonna go, but maybe the default is always gonna be at least like 0 or something. Yeah, okay, so let's actually go ahead and do that. And that's the thing. That's the thing. All right. And I guess now we just have to go ahead and initialize everything, I suppose. Right, so let's start with the boolean. So we're gonna have a flag, and we're going to take the flag from flags count plus plus, and we're going to take a pointer to this entire thing. But first we also need to boundary check. So flags count should be less than flags capacity, right? Should be less than flags capacity, so we have a flag in here. So the next thing we do, we assign the type. The type here is a flag boolean, right? So it's a flag boolean. Then we have a name, right? So this is the name and this is the description. Right, so this is the name and this is the description. Do we need to have anything else? I think that is it. And the thing that we're returning here, we are returning the pointer to the data. We're returning pointer to the data and we're reinterpreting it like that. There we go. That will allow the user to actually modify this thing and do something with this entire thing. Okay, so let's go. So the same thing is going to be for the uint64. For the uint64. So let's also assert this entire thing. Maybe, you know what, maybe we could have like an internal function that automatically sets all of that, because we're going to be repeating that a lot. Right, we're going to be repeating all of that a lot. Maybe it could be even global function. If you know what I'm talking about. Maybe it could be a global function where you could basically say something like flag new, right? So this is going to be void star, and this is where you would accept a flag type, which brings the flag type into the user interface, right? So it becomes a part of the user interface. Right, so this is the type, and then we have the name and the description, right? So we have a name and the description. And essentially, that's what we're gonna have in this entire thing, right? So we're gonna put it in here. Yeah, I can even copy paste the entire stuff, pretty sure. So we're going to do assert, then we take the flag, we assign the type that we got from here, name and the description, and then we just return the pointer to the data. So because of that, the flag boolean is essentially going to be like a flag new, right? Flag new, where you say flag boolean name and description. And that is it. So, and this is going to be the implementation for all of these things. Which also probably means that all of these things may become a macros that just call to the flag new, right? Because you can replace flag boolean with just something like flag boolean name description, and you can do the following thing. It's going to be boolean star flag new flag boolean name and description. That's it. So maybe we can also wrap this entire thing. So basically, we can simplify the interface even further, right? You just specify the type of the flag, and it just returns you a pointer, and that's it. So you don't need to have anything else in here. So it's going to be even simpler than that. So we don't need this thing, we don't need this thing, we don't need this thing, and the entire thing becomes way simpler than it was. Right, so this one is going to be uint64. That means this one is uint64t, uint64, like this. So this is the flag. Okay, there we go. So and then we're going to have a string. Right, so this one is going to be const char pointer. I wonder if it's going to work actually. So it may not work properly, but we'll see. So we're reinterpreting the void star pointer into pointer to the pointer, but that's precisely what we want actually, right? It's going to be pointer to the pointer. There we go. Do you need casting to boolean? I need casting for pointer to the pointer to the boolean. Def should be set to 0. No, it shouldn't. It's going to be reset on the flag parse. It doesn't need to be cleaned up whatsoever. Why did he pull out the defaults out of the flag? Because you can get the defaults from the actual value, and I explained that. Do you need to copy the name and description, by the way? Only if you're getting the name and if the lifetime of the name and the description is smaller than the lifetime of the whole application. But that's going to be part of the interface. So basically, when you put name and description, you basically agree that the name and description is not gonna... that the whole application is not going to outlive name and description. So this is going to be part of the interface. And to be fair, the way you usually use flags, right? You provide the name like this, right, as the string literals, right? And the lifetime of string literals is the entirety of the application. And for the description, you also usually provide something like a string literal, which is also has the lifetime of the whole application. So in a majority of the situations, the lifetime of the thing that you put in here is the same as the lifetime of the whole application. So there's literally no reason to put a very complicated structure that allocates the memory and copies the thing and stuff like that, because that's not what you usually do with the library anyway. It's like if you do that, you have a really weird case and you should probably not use this library. You know what I'm talking about? So you don't need to overcomplicate. My answer to you, Ozzy cheat code, is that you don't need to overcomplicate this library at such an early stage, considering that you probably never will need to do that. You see what I'm talking about? Right, it's all about like lifetime, right? So, and usually the stuff that you put in there, it has a big enough lifetime, so you don't have to worry about copying it. And if you put something there that has less lifetime, well, you're probably using this library incorrectly, and maybe you should not use this library at all. Maybe you should use a different library. So maybe you're doing something different. You know what I'm talking about? Does it make sense? It does make sense to in my head. Like, it's just like, yeah. So there's no reason to overcomplicate this thing, because that's not what you're usually gonna do. All right. So we have a parse in here, and I think that's Gucci. That seems to be Gucci. That seems to be Tamaguchi. Alrighty. So and now we just need to go ahead and parse this entire thing. Oh, maybe we can implement first printing of this stuff. Right. We can try to implement the printing because that's the easiest thing to implement in here. If you know what I'm talking about. If you know what I'm talking about. Interestingly enough, what if I print help before I did any parsing? So the idea, by the way, here is the following. So about the defaults, you never set the defaults via the function. You basically I'm gonna say that again because some people missed that. Right, so we're gonna have something like uint64t, which is the size, which is the pointer. So this is gonna be flag uint64, right? Some sort of a size, right? Size, the size. There we go. And then you set the size to a particular value, and that's your default. That's your default, right? And the way we're going to print that with the print help function is when you do a parse, we're going to be iterating through each individual flag, right? Flags count. There's going to be flags, and we're going to be basically setting the default to the current value. That's it. And then when you do the print, we can use that default to actually say that was the default. But here's the thing. What if you call print before you did any parsing? So how are you supposed to resolve this situation? You now need to mark whether you already collected the defaults or not collected the defaults. So, you know, it's kind of messy. That's what I want to say. It's kind of messy, and I'm not really sure if I want to do it this way. It's kind of, maybe we should bring the defaults back. Right, because we don't know at which point, and it's actually super easy to shoot yourself into the leg, right? So it's super easy to shoot yourself into the leg. So I'll need to think about that. Okay, so before we continue the development, I think I want to make a cup of tea because I didn't make a cup of tea before the stream, right? So, and I'm regretting it yet again. So let's go ahead and make a cup of tea. All right. So I think we do need to bring back the default thingy, and because we need to bring it back, we need to also get rid of this macros, right? So I could probably provide the default value like uint ptr, but then I would have to convert the default like this, right? So I'll have to convert it like this, and who knows how C will decide to convert all of that. So you actually need to reinterpret the bits and stuff like that, which is not particularly convenient, I think. So I think this is going to be purely an internal function, right? So this is going to be purely an internal function that the rest of them are going to be using. But the thing is, it's not going to set the default. So the default is going to be set by the specific functions, right? Something like boolean flag. Actually flag boolean, right? So flag boolean, then it's going to be a name, and then the default, and then the description. There we go. So name and the descriptions. Okay, so now we have uint64t, right? uint64, and this one is going to be uint64t. There we go. So, and then we're going to have a pointer for this thing. And let's do it like that. So it's also going to be the default. All right, so so for the boolean, right? For the boolean, what we're gonna do? What I'm thinking is that maybe flag new should return the whole flag. Since it's for the internal usage only, we might as well actually return the pointer to the flag itself, right? So we are allocating a new flag, we're setting the type, name, description. We're not setting the default, by the way. We're not setting it. Yeah. It's going to be set by one of these functions in here, right? So flag new. So, and this is basically acts like a little allocator. Yeah. So it's a little allocator that allocates a new flag within like a linear region and stuff like that. And what we're doing here is just a name and description. There we go. We've got a flag. So then we need to assign the default. But the thing is, we can't really take the default and basically, you know, reinterpret it as uint ptr_t. We can't do that because then the C will try to convert things, right? Especially if you have something like float, right? In here, it will try to convert the float. What we have to do in here, right? We have to reinterpret, you know, this thing accordingly. So we need to take the pointer to the default, then cast it to the pointer to the boolean, right? Then dereference that pointer, and only then we'll be able to assign it. So we're literally reinterpreting on the level of bits, right? So that's what we're going to be doing, and then we need to return the pointer to the actual value, right? Like this. To the actual value. So, and we need to repeat this kind of stuff for all of the flags. We need to repeat all of that for all of the flags. Okay, so this is going to be flag, flag new, name and description. Right. And this one is going to be uint64t. And then I'm going to be returning this thing like that. Though this is not void star, that means it won't be easily converted like that, so I'll probably have to also reinterpret this thing like this. There we go. So in this one is going to be uint64t pointer. There we go. So this one is called uint64 because I copy pasted this entire thing, so let's not do that. So this is going to be str. There we go. Flag new, name, description, and then flag default. What we're going to be doing? So this thing is supposed to be const char like this. And then we're going to be assigning it. Well, default has to be like this. Yeah. So the default has to be like this. The default has to be like this. And then we're going to be doing it like that. There we go. So then what I'm returning this thing as a value. flag value. There we go. So cool. Now we have everything associated properly, hopefully. So I want to test this module somehow. So let's have something like test flag.c, right? Here we're going to be including the flag module, right? And we're going to be parsing the arguments, right? We're going to be parsing the arguments. We also need to define flag implementation, right? And let's try to define a couple of flags from our application, so we can take a look at them. Oh yeah, by the way, did you guys see this thing? Like our application has a not a potato flag. So yeah, so you can actually take a look at that. So look. So here's the help, and if you take a look, there is a flag, not a potato. And what this flag does, it confirms that your machine is not a potato, whatever that's supposed to mean, right? And the reason why I have this flag is because if I try to allocate like a huge tiles, right? I don't know, so maybe 124 and then something like this. I think it is going to work. Yeah, it will take some time because it will output PNGs, so we can also say don't output PNGs. So hopefully that will be a little bit faster. Right, and for some reason I can, and furthermore, not for some reason, furthermore, I can make a very big grid, right? So if you try to do the rendering on very like big surfaces and stuff like that, yeah, you may start allocating more than 2 GB of memory, right? And on my machine that kills the entire system because I have 8 GB of RAM, but it's usually already taken to the brim by all the other applications and stuff like that. And allocating 2 GB actually starts to swap a lot. And when my machine starts to swap, it just basically locks. So essentially, I made like a small safety mechanism. So if the application is about to allocate this much of memory, it won't allow you to do that unless you provide not a potato flag. So I don't want to limit people who will run this application to do like a very big stuff, but at the same time I want to be safe, you know, from actually killing my entire machine. Right? Does it make sense? All right, so yeah, let's actually have a couple of flags in here. So yeah, I can have maybe live, which is going to be boolean, right? And we can say flag boolean live. By default it's false. By default it's false. And so what was the live flag? I don't quite remember. So animate the renderer, blah blah blah. So this is going to be the description. There we go. So here's the live. Animate the renderer and render the wank tiles in real time in a separate X11 window. Okay, so we also have we're gonna have no PNG, boolean no PNG. By default it's false. So don't output. So I'm using like a real you know, application case just to test my library. So and the last one is going to be potato. The potato flag boolean not potato. It's going to be by default false. And then what you do, we confirm that this entire thing is not a potato. There we go. So after that, I may try to print the help. So print help, and I'm going to print it to std out. So this is basically what I want to test in here. So this is going to be return, and let's do gcc o test flag.c, and it is not working because we don't have any of this stuff in here. So I think we need to include stdio, right? So we also need an assert in this module for sure. And we have a name, incompatible flag new. So flag new apparently. So what does it say? Incompatible type for like new flag. Oh yeah, you have to provide the flag type first. Okay. So yeah, first flag type. Okay, flag boolean. So here's the boolean. Then we're gonna have flag uint64, right? So here's a flag uint64, and then we're gonna have a flag str, right? Flag str. There we go. So has no member value. I think it was called data, right? So we'll have to go through all of these things and rename it to data, right? There we go. And yeah, so this is already a dead situation. Cool. So everything seems to be working correctly. And another thing, since we have the default, maybe we should instantly initialize the default, right? So we set the default, and on top of that, we can also set the data as well, right? Makes sense? And then here we can set the data as well, right? And where is the other one? Here's the other one, so here's the data. For some reason I didn't put any parentheses in here, which I probably should, right? For the consistency at least. Maybe it's not that important, but for the consistency I think it does make sense. Right, so there we go. There we go. Why not use void star for flag default? Void star, void star, void star, void star. What's the difference though? How is that gonna help me? Because I'm storing the value inside of the value of data, right? I'm storing it inside. So if I'm gonna do void star, I'm storing it within the pointer, but that doesn't reduce the cost, right? So I'll still have to do, yeah, I'll still have to reinterpret this thing as the pointer to something else because I want to store inside of the pointer. It doesn't reduce the cost, like it just doesn't. I don't see it at least. Maybe you know some secret knowledge about C, but I don't see it. All right, so yeah. So I'm storing the data within this value, I'm reinterpreting the bits of this value to be the bits of the thing that I want to store in there. You can think of it as a union. So I'm just basically doing the union, but without using the unions. Does it make sense? I don't think void star actually helps with conversions and stuff like that. I don't think so. Maybe I don't understand your question, so I don't know. So one of the things we can have in here, maybe we can make it a little bit prettier, right? So we can say boolean def slot. Maybe it's more verbose that you don't care about the type. I do care about the types. I even have an enumeration that keeps track of the current type of the flag, and all of the functions return specific types. So all of the functions are actually type safe. I do care, like I actually care very much about the types, because in my opinion, static typing and type safety is very important for catching errors. The type of the pointer, I mean. The type of the pointer. So you see, I care, like all of the pointers are typed in here. Am I crazy? What are you guys talking about? I'm actually caring, like I'm actually a Haskell developer. Believe it or not, I program a lot in Haskell and I care a lot about the types. So telling me that I don't care about the types is like, bruh. I fucking care about the types. Types are very fucking important, and types actually help me to catch a lot of errors. And here are the types, right? I explicitly making all of my interfaces in here very, very type safe, so you will never make a mistake while using this library. You see what I'm talking about? So I think type safety is a very important thing. I don't know what you guys are talking about. I care very much about the types. Maybe it's you who don't care about the types by suggesting using void star. Maybe it's you who don't care about the types. Because the person who doesn't care about the types using void star, yeah, that's the person who doesn't care about the types would use. They would use void star. I use void star because I care about the types. So I think you guys are projecting something. I'm pretty sure you guys are projecting something on me. So So I'm gonna do my thing. You guys do your thing, okay? So if you want to write a buggy software, you know, more power to you. All right. So what do I want you to do in here? Only flag new is typeless? Where do you use, like, it returns flag, which is the type? You guys are trying to, you're trolling me, literally. Look how, look, it's types, it has, okay, you guys are literally trolling me at this point. Okay, so you guys do your thing, okay, so I care about the types. Okay, so this is gonna be def slot. And that's basically what we're gonna have in here. So then we have the data slot, and this is the data. There we go. And then I'm not sure, it would be kind of cool to just do it like that. So here's the default and then data slot, the default, and then I just return the data slot, if you know what I'm talking about, right? So yeah. But again, it's just like you adding 2 lines without any particular benefit. So the code maybe becomes less noisy, but at the same time, it's just like very easy to make a mistake in here. So I'm not going to do that. I think I'm not going to do that. Also, what I want you to do, I want you to enable a couple of warnings in here just to catch some errors, because I do care about errors and types. People are trying to accuse me about all sorts of things, right? That I don't care about the types, something is typeless, or whatever, like, I don't know what's up with that. I don't know what's up with that. Okay, so here we have that, and so after that I want to print. Okay, so that's fine. Now, it's going to be flag.h. And what we're going to be doing, I want to just iterate through each individual flag. So it's going to be for size t and stuff like that. Uint pointer stands for pointer math with not caring about type, which is not possible with void star. So if you do not need math with pointers, you should use void star. Math with pointers, void star. Okay, I'm gonna explain it one more time, and I'm not gonna be explaining it again. So basically, the reasoning is the following. All of the types that I'm using, they fit into 64 bits, right? So they fit into the size of the architecture. So this is the type that can hold a pointer. That means it's of the size of the architecture. So I'm using it as a storage. So that's basically it. So I know for sure that the types I work with, they fit in here. So, and that's the whole reasoning. So I could have used union and that would be working fine. But I decided to do it like that because I like red bike sheds, right? I think they're pretty bright. I really like bright bike sheds. Does it make sense? Does it explain everything? I already explained it when I actually started like typing this code, but maybe some people missed some things. It's the same with void. Yeah, I suppose. I think it's the same with void, but as I already said, I prefer my bike sheds to be red. I'm sorry. Like, if the red bike sheds offend you, I'm really sincerely really sorry. And it is what it is, and there's nothing we can do about that. So if you prefer green bike shed, it's totally fine, but I personally prefer red bike sheds. So, sorry. It is what it is. Red bike sheds are the fastest, exactly. They are the fastest. They are the fastest. So, does that make sense? Does that make sense? Hopefully. Hopefully that makes sense. All right, so I hope we agreed on the color of the bike shed, right? So the bike shed is going to be red. It is what it is. If you don't like that, I'm really, really sorry. sorry. That's why I wear a red t-shirt, because I like red bike shirts, right? So that's precisely why. Okay, let's iterate through the entire thing, and it's going to be flag count. I think it's a flags count. Yep, let's do it like that. Printf std error, and I think we're going to be doing something like this: 1, 2, 3, 4. Then we're going to have a flag. And do we gonna have a description right away? I don't think so. Let's actually not put description in here. So it's gonna be something. Not std error, excuse me. It has to be stream, right? I actually store all my code in bike shit. Yes. 2, 3, 4. 1, 2, 3, 4. And here we're gonna have the description. And this one is rather interesting. Right. So this is where we're probably gonna put the default value. And this is where the keeping track of the type will come and play, right? This is where it will come and play. So, and, okay, so this is going to be flags. We take a flags I name, and here we have a flags description, right? So here's the flags description. Maybe I'm not going to put this thing like this right now. What we're going to have in here is, I don't even know, man. So we need some sort of a way to print the default of the flag, if you know what I'm talking about. We need a way to do that. So maybe we're gonna have a function, an internal function, flag print default, where we're gonna accept the pointer to the flag, right? And this function is going to go through all of the types of the flag, and depending on the type of the flag, it's gonna reinterpret the default value accordingly, right? So that's gonna be the plan, at least. That's gonna be the plan, and yep. So let's replace this thing with that thing. And this is going to be case, and there we go. So let me see. So this is going to be a break. There we go, and it's going to be f print f. I think I could make it more generic, probably. I think I could make it more generic. Essentially print the value, right? So print value. Man, it's not gonna really work well because it's not gonna be super convenient to do the thing, if you know what I'm talking about. But the idea is the following, right? Print value, you would provide the type of this value, so basically flag type, and literally you int ptrt the data, right? So you would provide this thing, and then depending on this thing, oh man, I'm losing the flexibility of the formatting string, unfortunately. I'm really losing the flexibility of this thing. Maybe we could print it into separate buffer or something like that. You know what would be cool? You know what would be cool? It would be cool to have this thing as char flag show data. I would provide the type and the data, and it will return me a sister thingy, and then I could say, okay, then default is going to be s, right? So the default is going to be s, and then I can say flag show data, flag I type, and flag I default. Right, and this thing would basically reinterpret this thing according to this type and render it into a character. But the thing is, we need to somehow manage memory for this thing, you know. So you creating a string out of that, but where you're getting memory for that string. And this particular thing would be super convenient, by the way. The reason why it would be super convenient is because now I can turn into string not only def, but for instance data, right? So yeah, and it just makes it super easy to work with these kind of things. And in the future I'm gonna have like a range checks, and maybe I will be able to show the minimum or the maximum depending on its type. So this thing becomes like sort of a, it becomes a union essentially. It's a union between several things. Right. You know what I'm talking about? So yeah, basically that. But again, where can we get the memory for the string that we're trying to render? Where do we get the memory for that? That's a good question. Maybe we're gonna be having this memory in the same place where we have that thing, right? So yeah, we can have something like static character, and this is a temporary memory for string, right? It's a temporary memory for strings and stuff like that. So flags tmp str, right? So, and this is where you can keep this stuff. So, and what's going to be the capacity? Flags tmp str capacity, right? So, and you'll be able to control the capacity of this entire stuff. So the good flags tmp str capacity. If it's not defined, right? If it's not defined, we're going to be defining the entire thing. And how big do we want to have it? I'm going to allocate like 1 kilobyte of this thing. I don't think it needs to be very, very big, right? And yep. I'm gonna have static size t, flags tmp, size initially 0. So, and essentially the show data is going to allocate the memory from this specific buffer. It's going to be allocating from this specific buffer, and at any point once you're done working with temporary strings, you can just set this entire thing to 0. There we go. So that's going to be the idea. So we have like a buffer. And yeah, so while we're printing the help, we're like using temporary things, and then we're done with this entire stuff. We might as well even do that on each iteration. We can clean this like temporary buffer on each iteration. So should be fine. Should be actually fine. Furthermore, maybe we could allocate a small buffer on the stack. Well, this one is rather complicated. Strings, if I have strings, sometimes this thing will not return memory that points into the internal thing. Because when you're reinterpreting the type, right? When you're reinterpreting the type, when you're reinterpreting the type, if the type is a string, right? If the type is a string, what we can do in here, so we'll probably have to do the case. We need to take the pointer to the data, reinterpret it to const char like this, and then do it like this. So you see, sometimes flag show data is not going to be is not going to return a string that points to that temporary buffer. It's not always going to be like that, unfortunately. All right. So because of that, so is that a fine thing to do? I guess I'm gonna spend a lot of time just contemplating if I'm not working on it. Okay, for the boolean, by the way, for the boolean, we can simply reinterpret the entire thing to the boolean, right? So it's gonna be pointed to the data. We're converting it to the boolean, right? And then we are dereference the entire thing. And if it is this stuff, right? If it is this stuff, we're going to be returning true, right? So we're returning true, or we're going to be returning false. Might as well use ternary operator for this thing, right? So this is going to be return like this, right? So this is going to be true, and this is going to be false, right? There we go. So you see, we already have two cases where no memory allocation is required, right? So the only memory allocation that is required right now is the one for the uint64, right? The one for the uint64, right. And how are we going to be doing all of that? That's a very good question. So we could use something like ascendprintf, right? And I really hate ascendprintf because it never returns how much it's written. It actually returns how much it would have written if it had enough space. So you have to do this, like, you know, arithmetics and stuff like that all the time. And on top of that, it returns -1 in case of an error, which is very annoying. So ascendprintf is just like not a very good function. Holy fuck. This is not a very good function, but that's the one that I have to use right now. Right, that's the one I have to use. And it is what it is. It isn't what it isn't. And as we add more of these things, yeah, we're gonna be doing more of the other stuff. Okay. So let's take a look at the interface of this ascendprintf. Ascendprintf. So it first accepts where we're going to be writing it. So flags tmp str, but we're actually writing it into tmp str size. This is where we're writing all of that. So how much space do we have? Well, we have space flag tmp str cap minus the size that we already have in here. So that's why I think that ascendprintf is a very annoying function, because it forces you to do this kind of stuff. Right? In my opinion, it is very annoying. So now we want to print this thing. So we have to print it like that. Since we don't have a special formatting arguments for uint64, you have to use something like pri u64 or something, right? And then you have to take the data, right? You have to take the data, point it to the data, reinterpret it as uint64, right? And then dereference it. Okay, and this entire thing might return you how much it's supposed to write in there, right? It's supposed to return how much it's supposed to write in there. To be fair, we not necessarily have to write anything. As the first pass, so here's the buffer, right? So here's the buffer. As the first pass, we can just try to estimate how much memory you want to write in here, right? And again, ascendprintf may return -1 in case of an error, right? So return ascendprintf do not write more than size bytes. So if an output error occurred, negative value is returned. So we have to assert and equal to 0. There we go. So that's basically what we have in here. All right. So yep. So basically, with the first ascendprintf call, we're estimating how much we will write into this region, right? How much we'll write. Then we're asserting that no formatting error has happened because of this kind of stuff. And then we need to assert if we even have enough memory. So we need to do flags tmp str plus size n should be less or equal to the capacity of the memory that we're trying to fill, right? Right, and if it's not, that means we don't have enough memory and you need to increase the capacity that you allocated for the flags. But usually I think 1 kilobyte should be more than enough for this kind of shit. All right, so, and after that we need to perform the second call, right? So we're performing the second call, this time already writing this entire shit into the flags team pstr plus the size of this thing. There we go. So maybe I should actually, I don't know, so maybe I should keep track of 2 pointers or something. Oh yeah, that's a good point. So basically, you don't really need to specify how much you have. Okay, that's a good point, I think. Right, so this is the first estimation, and yeah, so we're trying to estimate, then we're checking that nothing. This is a horrible function. I absolutely hate it. Okay, so yeah. And then the next thing we do is this thing plus n, okay? And it can actually change, like there is a room here for the n to actually change. You see what I'm talking about? Like, what if you have this situation? Okay, so I'm gonna do it like that. So we're kind of assuming that this thing is gonna be equal. But because we're forced to perform 2 calls, there is a room for this thing to actually return something else. That's why I think this API is absolutely horrible. There is no reason for this API to be this error prone. You know what I'm talking about? Like, yeah. Well, we're calling it with the same argument, so it must return the same value. But how do you know that it does return the same value? Well, you don't. The API is shit, so... It's just like, holy shit, it's so bad. To the point that maybe I should write my own function that renders you in 64. You see what I'm talking about? Like it's easier for me to write my own function that does that. Oh, this is so bad. Holy fuck. So, well, and with enough asserts, maybe we can survive, right? So we're asserting here that there is no formatting. And what's interesting is that in case of sendprintf, you may not have errors because of the I/O, because you're just writing into the memory. So there will be no I/O errors, but still this thing may fail because you provided incorrect formatting. But I provided correct formatting, so correct formatting should be checked at compile time, but instead it's checked at runtime because the API is shit. Right, and there's so much room for mistake in here, it's insane! Like, I keep looking at this API and I just like keep finding more and more ways to make a mistake in it, and it's just insane. Holy fuck. Yikes. Does stbprintf, is stbprintf even a thing? I don't know if it's even a thing. Nothing. So I never heard about printf. Just a second. Printf. But I mean, it's as printf actually. So. But I mean, it's just a clone of printf, and printf by itself is a really poor API. So I suppose this thing is needed for the code that cannot use standard library, but still depends on printf. I don't think Sean implemented this library because he thinks printf is a good function. I don't think so. Let's put it this way. So I don't think you use this library because you like printf, right? I think the situation you use this function is because you need to compile your program in an environment where you don't have a standard library, right? But the code depends on printf and there's little you can do about it. So you just slap this thing there and it works. So I think Sean recently said sprintf is faster, but I'm not talking about the speed, by the way. So I'm not criticizing printf as an API for its speed. So speed is irrelevant. What I'm talking about is the usability of API. Yeah, speed is irrelevant in this discussion. I'm sorry. so okay. How can I implement this function myself? So I know how to print the unsigned integers, right? But the thing is, you have to collect this stuff into the buffer, right? You have to collect it into the buffer, and all right, you can just keep writing that thing into the buffer, and then if you hit the capacity limit, you basically roll back and you say that you can't do that, right? So the function that will do the thing should probably return Boolean, indicating that it succeeded or not succeeded, or whether it's overflow or not. It will accept the beginning of the buffer, the capacity of the buffer, right? The buffer capacity, and maybe maybe the value itself, right? So it should accept the value itself, right? So in the buffer capacities, this thing should also be like so. Okay, maybe not today, because my brain is currently thinking about the rest of the things. I think I'm going too much into this rabbit hole. Maybe at some point I will think how to implement it in a more clean way. So we need to have int types in here, right? So let's introduce int types. All right, so here we have a return, and in case of the default, we have to maybe do something like assert, saying that this thing is unreachable, right? Unreachable, there we go. And in case of unreachable, I think we also have to exit with 1 or something like this, reaches the control. Discards, oh yeah, so, and this is where we're starting to have like a lot of problems with const correctness and stuff like that, because we're holding a pointer to a const pointer, and the const qualifiers go down as much as, like, they don't support like 2 levels of indirection. It's just like, fuck. I suppose I have the following idea. I suppose for the string values, when we're talking about string values, we're gonna be using just char, right? So this is gonna be char without the const, because we are starting to work with pointer to the character, and it's just like const correctness stops working there all of a sudden. There's so many problems with const correctness, like holy shit. It's like a cool idea in at the surface, but once you start digging into it and applying, it's just like huge pain in the ass. Okay, so here is the thing, and I suppose, oh fuck, and it also, you also have to keep track of the null pointer and whatnot. So ascend printf also null terminates everything. Const-char is a valid type. It is it? I remember having problems with this kind of thing. So essentially, I remember, so let me see, test flags. Let's remove this entire thing, and I have a pointer to a character, right? So it's something like this. It doesn't matter what it is, right? And this entire thing should compile, I suppose. Oh boy, okay, so it's too many preparations, because, okay. stdio, std-leap, right? So stdio, std-leap, p, and let's also make this entire thing something like void. Right, there we go. So it's compiling. Now I have a pointer to the thing, right? So what do you think? Do you think this code will work? Well, let's start with this code, right? So something like this. Will this code work, or I mean compile at all? So you have a non-const pointer to character, and you're assigning it to a const pointer to character, right? It would make sense. That you can assign modifiable to a non-modifiable thing because it's safe. What's unsafe is assigning non-modifiable thing to modifiable one. right? Basically getting rid of the const. And that will work. Right, that would work. So we have a situation that you have an unused variable, but that's fine. I can even remove the warnings and stuff like that, but maybe it makes sense to actually keep them. Okay, so what if we go to the one level of indirection further? Will that work? Theoretically it should, right? So it's the same logic, right? You're assigning modifiable thing to a non-modifiable one, which is safe, right? So it's absolutely safe. If you don't modify a modifiable thing, you do no harm, right? So it should be safe. Will that work? Let's see. I don't remember if it will work or not. Yeah. Well, I mean, it will work, but the compilers will complain. Initialization of const char from incompatible pointer char star star. So these things are not compatible. These things are compatible, but on one level of indirection they're not. Even though logically they should be, right? Again, we're assigning mutable thing to a mutable one, which is absolutely safe, but you can't do that. So, and it will work like that across several compilers. I mean, it still compiles technically, you can just don't care about that, but the compiler will warn you about this. Right, if we do clang, clang, as far as I know, will also tell the same thing. So, initializing const star with an expression char discards qualifying in nested pointer types. So, here's the thing. Nested pointer types discards qualifiers. So, one level of indirection further, and everything is discarded. So, that's how it works. So that's the problem that I actually encountered recently, and I had to like force cast it. So I'm not sure if that's what you meant. We have flies in here. So does it make sense? Just found you're Russian. I thought you're American. No. All right. So, and because of that, it's just easier to not care about const. Hey, wee brother, K-Code. Not sure. Yeah, it's really weird. So, and when I was talking about like const correctness and problems with it, I had this specific example in my head because I recently encountered it. Right, I recently had a problem with this exact thing. It's not a problem, but again, the warning is kind of annoying. If you know what I'm talking about. The warning is kind of annoying. Okay, so maybe we can just like not care specifically for values. Right. And let's do it like that. Alright, so what do we have? So flag is your conflicting type. Okay, so we also have to update this thing. Right, for the name and description, okay, we can use const, but for the rest of the stuff, well, it is what it is. stdlib, right, and do we have anything else? So we have some warnings, show data, help, okay, so this is a dead code. The execution may... why do I have flies in here? Why do I have so many flies in here? You know what's funny is that flies... my windows are closed. I don't know how they got in here. So... so the control may reach, but it won't reach. Well, that's weird. Well, I mean... So flags, flags. Okay, cool. So we've got that. And again, I forgot completely about null termination and stuff like that. And you should not forget about null termination for this entire thing. Oh boy. Send printf. Null zero termination, right? Okay. So the function is printf is write at most size byte, including the terminal null byte to str. So do they return the do they count the null? return. Upon successful return, do not write more than size byte, including size. The output was truncated due to this limit, then the return value is the number of characters, excluding the terminating null byte. Okay, so they exclude the terminating null byte. Nice. So essentially that means you have to treat it like +1. Right, so you do that thing. Right, so you assert that that thing fits in there. Then we check for that and we actually add +1 in here. There we go. So that also includes the null termination. All right, I love this. I absolutely freaking love this. Okay, so now if I go to test flag, right, and I think, yeah, so I already trying to print the help. So let's try to run test flag, and yeah, it almost worked, by the way. It almost worked, I just forgot the new lines in some particular places. So there we go. So what are the new lines I forgot? I think I forgot to put this thing in here. There we go. And maybe I can do something like this, test flags. There we go. Here's the output, right? So yep. So we have that. Animate and render, so default false, and so on and so forth. Maybe we could actually put the defaults on separate, like, lines, if you know what I'm talking about, right? Because we're also gonna have min and max and some other stuff, right? So we could try to do it like that: 1 2 3 4, 1 2 3 4, defaults as, and this is how we do that. This is how we do that, and then I can just do it like that. There we go. Yesu, kawaii freaking desu. So yep, so this is the output. Does it make sense? Right, live, animate and render, default false, and so on and so forth. So that's pretty powerful, not gonna lie. It took some time to do all of this, especially with these kind of things, but I think we managed to do that. Yeah. So now we need to implement the actual parsing of this stuff, right? So we want to implement the actual parsing. And how are we going to be doing all of that? We're going to be doing that by iterating through this entire thing. So we know that the first program is the first argument is going to be the program, so we need to actually exclude it. So I'm going to be using my shift args thingy. I'm going to include it into the library, so it's going to be flag shift args, so this is the static thing, right, and that's how we're gonna start. So it's gonna be const char program flag shift args, so argc argv, and I'm gonna just keep it in here, but I'm not sure if it's that important. I remember when you wrote this shift args for the first time on the stream. Yeah, it was actually kind of cool. So it's a 3-star thingy. I was actually surprised that it was so easy to come up with the example with 3 stars. Right, so 3-star programming, yeah, I suppose. That's me, probably. I don't know. It's a very simple example, though. So while args is greater than 0. Did you hear the fly? Okay, so we're gonna have char flag and flag shift args argc argv. Right, and essentially we're gonna be iterating through everything, right? Though if flag starts with this, we may actually do something like this. If it doesn't start with dash, we have to sort of fail. By the way, does parse fail? How does parse fail? I don't really know. So here's the parse. Parse must be called after. Okay, so parsed reports whether the command line flag have been parsed. Okay, so must be called after all flags are enabled before flags are passed successfully. I don't remember how you handle the errors though. I think the thing fails for you automatically. I think it does fail for you automatically. Anyway, so if it's not equal to that, we're going to be printing something like error unknown, so maybe even something like this. Unknown flag, and this is going to be flag, and we just exit. Why the fuck does it bother me? All right, so here's the thing. We provide the name without the dash, right? So that means to compare everything appropriately, we have to do something like flag +1 to get rid of the dash. We already checked that it starts with dash, and if it doesn't start with dash, well, it's an unknown flag. So, and that way we're sort of like removing the flag at all. So the next thing we need to do, we probably need to iterate through all of the flags that we have. So it's going to be flags I and flags count, I would even say, right? So this is going to be flags count. If flags I name strcmp equal to flag, we found the flag, essentially. We found the flag. And it will depend on the type of the flag, right? So all of that shit is going to depend on the type of the flag. So of course at the end we just break out of this loop and continue everything, but here we'll have to probably check. So if I switch upon the flags type, right, so if switch upon the flags type, so it's going to be flag boolean, right? If it's boolean, I don't have to do anything, I just set the actual value, right? So this is going to be data, I have to reinterpret it accordingly. Have to reinterpret it accordingly. Then boolean star to true, and that's it essentially, right? So if it's boolean, I just set it and I don't care about the rest of the elements. If the flag is str, right, that is not enough. I'll have to get the next argument in there, right? So, and the way we're gonna do that, if this is annoying, so let's put it like this. If argc is equal to 0, that means no argument is provided for the flag. It's going to be fprintf std error s no argument is provided, no argument provided, right? And we provide the flag in here, and then we just exit with 1 in here. There we go. Otherwise, we have to say something like arg flag shift args argc argv, and there we go. We have an argument, and we can take the data, reinterpret it as pointer to the character, and just reassign this thing back. There we go. So that was relatively easy. This won't work for flags like equal x. Yes, it won't. You want to know why? Do you know why it won't work for flags like flag equal x? Do you have any hypothesis why it won't work for this kind of stuff? Because it's strcmp. No, because the program is not finished yet. That's why. All right, so okay. Zozin, your program is unfinished. Ah! Oh! Oh! Let's make a break. It's really exhaustive, right? Seriously, it is extremely exhaustive. Let's make a break. I'm gonna make a cup of tea and we're gonna continue working on unfinished program. I know, absolutely disgusting. I'm streaming unfinished program, but it is what it is sometimes. Okay, I've got my tea. So let me see. So here's the flag. Here is the other things. So yeah, if the arg is equal to 0, so that's everything's fine. And yep, so the next thing I need to do, right? Next thing I need to do, I need to check for the case flag uint64, right? If the flag is uint64 in this particular case, right? We need to start parsing it. So as far as I know, to parse uint64, I need to str to ul. Why this? Yeah, so there's only one source of light in here, and this fly is just like bothering me for some reason. Okay, so here is the thing. I need to really kill it because it's been bothering me for 3 days already. So speaking of static assert, I think I want to statically assert in here that the size of this type, right? The size of this specific type is the same as the size of uint64t, right? Because that's basically what I'm going to use. I don't think we have str2u64, do we? str2u64, I don't think we have that, so it is what it is. So, yep, and we also need to check if we do have any arguments in here, right? So, and if we do have the arguments, we have to extract them. There we go. We have to extract them. So this is going to be the result, and we're extracting from the argument. Then we have the end pointer, which is going to be something like this, end ptr, and the base, of course, is going to be 10. All right. So if so there's a couple of things in here. I already explained how this function works. So we need to check end pointer not equal to 0 or arg equal to end pointer. Right, if this kind of situation has happened, that means the value is not correct. Stt error s not a valid number. Not a valid, yeah, let's call it not a valid number, and we're gonna just provide the flag and exit with 1. So, and there is another situation in here when the result is equal to I think it's ul long max, but I don't remember, so it's a basically unsigned long max. Is that a thing? Is that a thing? I think it's a u long max. U long? What is the double long? Oh, it's a I actually guessed it correctly. All right. And error no equal to e range. E range. That means we have a overflow. So 64-bit unsigned integer overflow. Yep. So, and this is going to be something like this. And here is the result. And once we parsed everything correctly, this is how much stuff we need to do to parse everything, right? We need to reinterpret the data, right? We need to reinterpret the data as uint64t, right? And just set the result. There we go. So that should be it, I suppose. Cool. So if we encountered any other things in here, so we probably need to set the unreachable, at least throw the unreachable situation, right? Default assert unreachable. And in case of this thing, I'm gonna put 69. So here's an interesting thing. In case of unreachable, I quite often just do an assert. But the problem with assert is that you can easily compile the program so it strips off all of the asserts. So, but you still want to crash in case of an unreachable situation. So I decided recently that I'm going to follow the convention, that I'm going to exit with the code 69. And if you strip off the asserts and you crash with the 69, at least you know that you're in an unreachable situation. Right, so that's going to be the convention that I'm going to be following. Alright, so can I compile the entire thing? I cannot compile, so I wish I could go to the errors. And I think we need to include limits for this entire thing. Right, so this is going to be limits. It's going to be something like this. strcmp, we have to do string.h. Anything else we have to have in here? So static assert with no message. Okay, so the original author designed this for x86 64 machine with the compiler that expects unsigned long int and uint64 to be the same thing, so they could use str2ull function to parse it. Please adjust this code for your case, and maybe even send the patch to upstream if you get a chance. To upstream to make it work on a wider range of environments. Yeah, wider range of environments. Usually I have to design this for x86-64 machine with a compiler that expects unsigned long int and to be the same thing, so they could use str2ull function to parse it. Please adjust the code for your case and maybe even send the patch to upstream to make it work on a wider range of environments. Right, so is this something that could ever happen? Probably, maybe, I don't know. Do you have a config for this compilation view? No, I don't, because it's a built-in feature of Emacs. I would recommend you to just Google up Emacs compile. Right, so yeah, it's a built-in function, and it works like that automatically, so you don't have to configure anything for it. So yeah. Can you access args before main? I think you can if you're writing your own _start function, right? So the real entry point to the program, right? So because it's responsibility of _start to prepare arguments and call main with these arguments. So I guess you can access the args before the main. All right. So, okay, let me see. And pointer, you have to take pointer like this. Error no, we don't have error no. Let's include error no. We depend heavily on the standard library in here, which is kind of sus about it is, what it is, and it isn't what it isn't. So we have only like 3 things in here. Oh, by the way, yeah. So I suppose in the flag, we're kind of using the program, and I wonder, do we really need the program for anything in here? That's a very good question. Do we really need it for anything? By the way, in Go, if parse fails, does it just crash or something? Does it just crash? Part of the command line. Does anyone remember, Go developers, how does it work? Does it just crash, or do you have to do anything special with it? Because I forgot. I think I have an application that uses this thing, so I can probably actually look it up there. So we have that. We just do that. Yeah, I guess it automatically crashes if you don't. Well, not really. Well, exit on error. You can customize this environment, this kind of thing. Okay, so maybe it could be customizable. All right. So I'm just thinking, do I want to print the thing or not? It's kind of hard to tell. Decisions. Okay. So let's not have that. We are not using the program for anything. Okay, custom error handling strategy. Okay, that makes sense. Test flag C, and let's print all of these things. Life. It's gonna be something like this. Live. No PNG, no PNG. Not potato. There we go. Here are the things. There we go. And if I try to do something like live, right, it didn't work. Beautiful. So that's cool. Did we ever actually call? Oh, okay. We didn't even call the parse yet. Okay, so I'm gonna do flag parse, and I'm gonna provide argc and argv. Right, so this is gonna be something like that. Ind argc argv. There we go. So now you can have live. If you remove it, you don't have it. No PNG. We have that, and we can also have live, and also not potato. Not potato. There we go. We can also have something like help, right? Flag boolean help. By default it's false, but print this help and exit this help to std out and exit with 0 code. Right, so that's basically what we have in here, and then after we parse everything, I can say if help, right, we're gonna do simply printf std out usage, and you have to provide the program. Oh boy, so yeah, decisions are hard. So it's gonna be test flags options, right? So here are the options, and then so this one's gonna be fprintf std out options, and then flag print help std out and then exit with 0, right? And only then we're gonna do that. Okay, so but at this point I can easily do help, and there we go. That's cool. So I really like this. This actually works really great. Though I'm not sure if printing default is that useful, but we can try. Okay, let's actually try to add more things in here. So these are just flags, right? They're not particularly interesting, they're just flags. So let's introduce another flag, something like uint64, tile width in pixels, right? So, and this is going to be flag uint64, right? And this is the pointer, right? Obviously it's a pointer. TW, initially it's going to be 1, so this is the initial value, and this is the tile width in pixels, and that's it. Right, so if I try to do help, it okay, so already something crashed. Let's see. Unreachable. Okay, so test flag, 85, and I forgot to well, excuse me. Oh, okay, I see. So that means I need to basically keep track of the result. I see, I need to keep track of the result. And the result actually starts at somewhere here. So, and then I can return the result. Okay, so that's why, well, I mean, unreachable still makes sense to keep track of, but yeah, okay. So yeah, that's perfect actually. Look, tile width in pixels. Tile width in pixels and default is 1. So it was super easy to add that thing in here. So then we're gonna do this thing, and maybe I'm gonna print like this. Tile width in pixels is gonna be PREU64, right? So, and this is gonna be tile width in pixels, and let me see, and if I don't include the help, it's going to be TW. No argument provided. Look at that. No argument provided. But there is a problem with this error, is that I forgot to put like a dash in here. So I'll have to go back to here and find all of the error reporting. So this is for the flag, this is another flag, this is another flag. So I think that's quite important. Okay, so there we go, no argument provided. And you can also check the help, right? So, and then TW69, and there we go, so it's 69 actually. So that's pretty POG, not gonna lie. What's interesting is that we can try to do something like this, right? And it will say 64-bit integer, unsigned integer overflow. You can provide some other shit in here, not a valid number. It only will work if you provide a valid number in here. There we go. So that's basically what we're gonna have in here. So yeah, it's already kind of working like the goes flag module, right? So that's pretty powerful. So there's other type that we also need to test. I want to test the something like Atlas PNG out. I think that's what we have in here, right? Atlas PNG. Yeah, so this is Atlas PNG. Atlas PNG is going to be flag str. Atlas PNG by default is going to be null. Well, by default we can actually say, oh my god, Emacs is too slow. It's going to be atlas.png, and the description is going to be something like this, right? Boom. So here's the Atlas PNG. That's pretty cool. Then I can do Atlas PNG is going to be equal to just a string Atlas PNG. There we go. So this is the Atlas PNG. If I try to take a look at the help, right? So we have an Atlas. There we go. We do have an Atlas PNG. So also put a dot in here, which is kind of weird. So maybe I should not print a dot when I'm doing this kind of stuff. I don't think it's valuable, but yeah, there we go. So Atlas PNG, default Atlas PNG, but at any point, right, if I don't print the help, so here's that, I can say Atlas PNG, output PNG. Is it going to be different? There we go. It is in fact different. So that's pretty close to our case, I would say. That is very, very close. The only thing that we do not support right now, chat, the only thing we do not support is minimum and maximum. Look, in the original application, right, if I take a look at the help, so the numbers can have not only default, but also minimum and maximum, right? And this is something that I would like to also support. And the question is, how can we support that? How can we support that? So here's the thing, when you create a new flag, right, when you create a new flag, you provide the default. So, and the more customizable parameters you provide, the more complicated this function call becomes. Right, so how could we simplify this thing? How could we simplify this thing? This is a very good question. This is a very good question. So how could we simplify this stuff? Does anyone have any ideas? Does anyone have any ideas? How can we simplify this stuff? So what will be the easiest way to simplify it? I have a following idea. What if we have a separate function like flag uint 64 min, which sets the minimum value for the flag, right? Which sets the minimum value for the flag. And how can we identify the flag? So sort of struct an arg with max and, well, yeah, that would be kind of nice, but it's not particularly convenient. So what would be more convenient, in my opinion, is to have a separate function that can set minimum and maximum for the flag. Right. But how can we identify the flag? We can actually identify the flag by the pointer that is returned in here. Flag uint 64. Like this. So, because we also point within the flag structure, right? We always point into this field, always, because that's the pointer where we return. And you know what's interesting is that we can also store such things as minimum and maximum in here. And since we know the pointer to here, we can quite easily calculate the offset for the min value and max value. So, and from the user perspective, it's gonna look like so. So you defined this thing, and then you say, okay, flag uint 64 minimum for this thing. Minimum is gonna be 1, and the maximum is going to be, I think it's something like this. Isn't that cool? So, and the user still can use this as a location from which they can read the actual value. So we're using it also as identifier. We're going to be using it as an identifier. Is that cool? I think it's pretty cool. So, yeah. And this idea actually does not overcomplicate the interface, because you still can just remove that and you have this simple interface, right? You still have this simple interface, but also it allows you to make more complicated things. For example, flag mandatory tile width like this, and there you go. You just mark the flag mandatory, and the parser will treat it as a mandatory flag. And it does not overcomplicate. If you don't want it to make mandatory, you just don't never call it. So, and the separate function calls make it super extensible. You can make it as complicated as you want, and also as simple as you want. If you don't need any of these parameters, you never call to these functions. You don't have to deal with massive function calls, because each individual parameter here is a separate function call. And yeah, you only customize what you care about. So that's the extension of the Go idea I initially wanted to have when I started this project. So yeah, and it's super easy to identify the flag that we're talking about by the pointer to its data location. So yeah, this is my take on the Go's idea on flags. So we'll see how it goes. Maybe it's a bad idea, who knows. Maybe I was thinking, maybe we could make the default value also something like that, but hey, I don't know. So, and maybe because of that, so you see we have a lot of this, other things. How to say that? Where is the flag structure? I lost my flag structure. There we go. We have a lot of these like slots that store the different values. Maybe I could basically turn them into an array, excuse me. like this, right? And depending on the type, this thing will mean different things. So for example, min and max will only be available for the size, but it's not going to be available for the strings, right? So, and then we can have something like, I don't know, data value, which is 0, then data default, which is 1, data min, which is 2, data max, which is 3. It's kind of a union, but without too much of the syntactic noise. The problem with the unions is that you have to make too many definitions for different things, and it's extremely annoying and extremely tiring. So it's like easier to sometimes just do it like that. And with union, I actually used a lot of unions throughout like compiler development. I developed my own compiler and stuff like that, and it's really tiring, and they're not even introducing that much of a type safety. As much as I like type safety, they're just not introducing that much, because you end up still checking first the type flag and then reinterpreting your unions accordingly. And this is the same thing, right? You just have this thing, you check the type flag, and you're still reinterpreting. You're not getting any benefits from unions. Did you start recording, by the way? I think I did. 1, 2, yeah, I did. So everything's fine. I'm always recording, by the way. So I never stop recording. I only put marks on where to make cuts. So even if I screw up the cuts, nothing is lost. I can just then manually go back and do the proper cuts. So basically, as I start the stream, I instantly start recording, and I only put marks on where to do the cuts. So yeah, so nothing is lost ever. All right, so yeah, so this is going to be the approach in here. So this is going to be the data, this is going to be the value, and so on and so forth. Yes, it's still a lot of manual work with enum. Yeah, so the enums are like have a great idea, but they don't really, at the end of the day, they don't really simplify anything, to be fair. They really don't, so I don't know. I wish they did, by the way, but they kind of don't. By the way, so maybe we can actually call it val, so they're, you see they're aligned properly or something. Maybe we could introduce enumeration here. So flag data, right? So we can do something like this. I'm sorry. Emacs sometimes is silly. Cool. So, yep. Basically different fields and stuff like that, and then you can be reinterpreting them. Okay, let's go through the compilation errors and just, you know, fix everything. Okay, so what do we have in here? So there's no def anymore, and because this is now a data, and it's a data def, and this is the data value. And the thing that we're returning here is in fact data value. So the pointer to the data value. Yep. So what else do we have in here? So data default, and data value. It's called val. Data def. Data val, type, data def. Yeah, we don't have any of this shit anyway. Okay. And here is the interesting thing. Now, what I can do. It also greatly depends on what type it is. So the default exists for any types, but min and max is going to exist only for the uint64. So if the type that you're talking about is flag, is it called type? Maybe flag uint64, we're gonna be doing the following thing. So we're gonna have a minimum, there we go. And we are showing now not the definition, but the minimum, right? Like this. And then we're gonna be showing the maximum. So what's interesting is that in case of a maximum, what's gonna be the maximum? Maximum should be the maximum type of uint64. So if we go to flag uint64, where is it? Yeah, so we probably need to set everything up, right? So here we have value, and then the minimum is going to be 0, and the maximum is going to be uint64 max. I think that's what it has to be, right? And if we do something like that, okay, so let's actually do help. Maximum is 1. What the fuck? I set maximum, but oh, I think I'm an idiot. So I didn't change it to max, right? And does it recompile? Oh, this is because we never actually... Do we set anything? Flag uint64. So here's the minimum, here's the maximum. What am I missing? Does anyone know what I'm missing? This is kind of sus, not gonna lie. Did I miss anything important? I don't think so. Okay, so... Alright, let me try to check that in the debugger. Alright, so I'm gonna do ggdb, right, and I'm gonna do gud test flags, okay, and I'm gonna actually break in here, so I'm gonna be breaking in here, and maybe I'm gonna be breaking here as well, so this is gonna be break. Right, let's run the entire thing, and there we go. So if I print, okay, so this is the next, let's take a look at the flag. So here is the flag, nothing particularly special. Inside of the flag, okay, so data is 0, 0, 0, 0. All right, so that makes sense. So I might as well even display the contents of this flag, and let's go. So it set the default to the default value, which is 1, right? And then the next one is 1. So the minimum has to be set to 0, the maximum has to be set to... Yeah, it actually was set correctly, as far as I can tell. Right, so this is the maximum value for uint64. I don't see any problems with that. Yeah. Okay, let's continue the execution. And did it now... okay, so I think I need to run it one more time, but with help. Okay, so boom, boom, boom. Everything is set correctly. Let's continue. And now we're getting here. Okay, so what I want to take a look at is flags I, right? So we might as well constantly display flags I, right? So just to be able to see what's going on, right? So, so we're printing that thing. The next flag is a help. So that is totally fine. So I'm just looking at this flag, at the flag name, and I'm trying to find the one that is TW, right? So I'm just trying to find the TW one. Not a potato, that is fine. Atlas PNG, TW. Okay, so here is the maximum, here is the minimum. All right, so here are the defaults. Here's that. Maybe there's something wrong with the data min and data max, but I'm not 100% sure. If you know what I'm talking about. Right, because here is the value. Yikes. All right, so let's... Okay, well, I mean, debugger actually helped. It forced me to go through the entire thing. Right, PRI U64 and PRI U64. Okay, so kind of. Oh, I have to reinterpret the entire thing, I suppose. Do I? Oh. Oh, no. It should be fine. Wait a second. It has to be string. It has to be string. It just have to be string. So there's something wrong with the flag show data. Fuck. There's something wrong with that thing. Okay, so maybe that's what we have to fix in here, I suppose. I'm reinterpreting the entire thing and it should be fine. Okay, let's actually go to the debugger. Got GDB like this, and then I'm gonna break in here. Then I'm gonna run the entire thing. Actually, I'm gonna run it with help, right? And in here I can print the data, right? So here's the data, and maybe I'm gonna even display it. Okay, so I don't care about data 1, so let's continue. So data 0, I don't care about it. Okay, this one. We can print... you always return in the pointer to the start of the buffer. Okay, thank you. That's a good point. Yes. Thank you so much. All right, so let's restart. Now, finally. Thank you. So now we need to be able to have an ability to set the minimum and maximum for those things. How can we do that? I already made the stubs for these things. Flag uint64, right? So here's the flag uint64. And the cool thing about this stuff is that I can literally now take the flag and reinterpret it as uint ptrt. There we go. Right, and I know for a fact the flag. So where's the flag structure? Flag. Right. So I will always point to the beginning of this array. So that means I can just do data min. Right, I can do data min. In fact, I don't even have to reinterpret anything. In fact, you can do it like that. But we have to statically assert that the size of uint64 is the same as the size of int uint ptrt, just in case. And that's it. This is actually a crazy hack. Holy shit. Oh wow, this is a... Wait a freaking second. Well, I mean, it will only work if the sizes are literally equal to uint64 ptr, otherwise it's not going to really work. But yeah, that's a very interesting idea. This hack will only work if the size of uint64 and uint ptrt is the same. So, and the same thing here. Okay, so this is going to be that. So this is the min. We don't have a min, so it has to be max. And let's recompile the entire thing. Okay, cool. So now, what we're going to have. So let me see. So 2 and now look flag uint64 tile width px. So I need to set the minimum to 1 and the maximum to 32,1024. There we go. So, but to be fair, default has to be slightly different. Right. So default has to be slightly different. It has to be something like this. Yep. So maybe for the like default things we need to have another padding. I think I would like to prefer to have another padding. 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Right. So yeah, I think maybe it looks a little bit better now. Who knows? Yeah, it's hard to tell. Maybe like 2. Right. There we go. Yeah, looks like shit. Hard to tell what's gonna look good. Hard to tell. We may probably wanna do something like this. So they looked kind of fine with on the same line, I suppose. This shit looked fine on the same line. Let's actually put it on the same line. I think it's gonna be fine. All right, so then we're gonna put the default. Right, I'm gonna put the default. Yep. So this is gonna be space. If it's that, well, we can also put like this. So this is this and this. Yep. And fprintf at the end of this entire thing is going to be stream new line or something like this. Cool. Yep. So we can probably put a space in here. Right, so that kind of worked, but you also have to keep in mind that in here we should not... This is annoying, because you may want to have... Okay. So what if you want to have several lines in there? That's the problem here. So it looks fine for these kind of things, but for other kind of things it doesn't look fine. Can't decide. Okay, so let's go back. Okay, I guess that's gonna be the final solution. Alright, so, and now we need to actually respect these minimums and maximums. Alright, we need to respect them. And how are we gonna be respecting them, I suppose? Alright, so we're gonna assign the result, but on top of that, min and max all on one new line? Maybe. So also this gave me an idea. If you want to set minimum and maximum, maybe you want to set them at once. Right, so flag you int range, and you could set it like this. So that would be rather interesting. So you would, because you usually want to set the whole range, right? You want to set the whole range right away. Do you want to set the whole range? We'll see. The winner gets T. But I think it's kind of a bike shading, if you know what I'm talking about. It's kind of a bike shading. So let's have it as a range. Where is the flag? I'm a little bit tired already, as you can tell. Range uint64t max min. This one is going to be range uint64t max. And one of the things here, by the way, we have to assert that min is less or equal than max, and then we can just do something like max max. There we go. So that will simplify everything. And because of this thing, do we want to... We can try this stuff. Okay. So there should be some separation. That's actually very interesting. Range. Is your sleep schedule good? No, it is actually absolutely horrible. Okay. Looks good. I think that's it. All right. So we could have more features in here, but for the rest of the features, I would prefer to create like separate to-dos or something like that, if you know what I'm talking about. Right. So there's definitely more things to support. But wait, we don't check the range. So let's actually do something about that. So the result, right? And if yeah. So this is the data, and I have to do data value, right? So this is the data value. Oh, no man. Let's do uint64t value, which is the result. Then we can have min, which is basically this thing, which is a minimum, and then maximum, which is this thing. And if min less or equal than val and val less than max, right? So and if it's not true, printf std error, error, the flag outside of the SS range, and we can just do minimum and maximum for this thing. Exit 1, right, and then we can just assign the value back. So that's what we're trying to do in here. So we also check the range. So something went wrong. Oh yeah, so I'm gonna need PRI-U64. PRI-U64, there we go. So is it working? Min max format specifiers type, but the so I have to provide the flag. Okay, so the thing I want you to do in here now, this is fine, but if I make this thing too big, yeah, outside of the range, and I think I forgot the new line, I can clearly see. Okay, so outside of the range of that thing, but if the range is small enough, it will let that go. So if I put 0 in here, it still says outside of that range. So now we can even specify the ranges. So if you specify too big of a thing, it will say that it's an integer overflow, and that is going really, really well. Right, so we're checking all of these cases and stuff like that, and well, this thing has to be valid before I can even print the help. So that's pretty cool. So that is working really, really well. Flag.h, and if I test the entire thing, so this is how you define all the flags in here, right? So you just declare them, you can customize their ranges and stuff like that, and yep. I was thinking maybe even the default value could be also one of these functions, right? Maybe the default value could be also one of these functions, but I don't know. And also mandatory and some other stuff. All right, this is good enough, I suppose. We probably want to extract it to a separate repo, right? That was my original plan, at least. Have it as a separate repo. So, and the interface here is rather good. It is rather good. So I wish we could get rid of this thing, but this thing is kind of like... It is technically possible to get rid of this temporary buffer. So the only reason why we have this temporary buffer is because it makes it easier to print things. Right, it just makes it easier to print things, but it's so annoying actually. So, would you mind showing how you check for overflows? Sure, str to ull. So this is the function that I'm using, right, to do things. It's a standard function. You can read, you know, documentation about it. What it does, it converts a string to unsigned long integer, right? And essentially, when it detects an overflow, the internet went down, by the way. So, but I'm still recording right now. So, are we live? Are we live? We must be live. So, I don't know. So there is a connection to Twitch, right? Okay, so we're seems to be live, right? So we're back. Okay, so since I'm recording locally, nothing is lost, in fact, so it's fine. Okay, so where did we stop? Where did we stop? To convert a string to a number, I use this function, and it is capable of checking the overflow. Right, so in case of an overflow, it returns the maximum possible value of the number. So this thing returns unsigned long int, and the maximum possible value is u max, which defined in int types, right? So it's actually defined in c-limits, right? It's a standard macro. So it returns the value of the maximum possible and sets error no to e range. And that's it. So basically the overflow is checked by this function, and it reports to me by returning the maximum possible value and setting error no to e range. So that's how I do that. Does that answer your question? Hopefully. Why is the range max value 32 to... because that's the value I picked that won't overflow some of my mathematical, you know, operations. So that's the safe value for my specific application. Do you plan to create a repo for this lib? Yes. For all of the STB style libs, I don't know, right now all of my STB style libs, they're separated in different repos. Will I ever consolidate them? Probably. I don't know yet. Maybe I will. What language? This is JavaScript. All right, so let's go ahead and create the separate repo. So how are we going to call this thing? Do we have to come up with a catchy name? We can literally just call it flag.h. You know, the JavaScript developers like to call their libraries flag.js or something like name.js, and we can use the same for our things. So it's going to be flag.h. C flags. Maybe, I don't know. The same as with Go, because the original one is called Go flags, right? I don't know. I suppose I'm gonna create the repo after the stream, because I'm already streaming for too long, like it's 3-hour stream, and I think we achieved everything we wanted to achieve. So we have this this library, and I'm gonna integrate it with the main application off screen. And of course, I'm gonna put the link to the source code to when I actually upload, you know, the repo. Okay, so basically source code to be done. Right, I'm gonna put it in here in the description for people who's watching on YouTube, right? If you're watching on YouTube, and if you're not watching on YouTube, check out the YouTube that we have in here. All right, that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. And we'll see what we're gonna do next time. So hopefully this thing was interesting, and I gotta go. Thanks everyone. Love you all. Mwah.